And now they finally let us factor. So, currently, and I'm going to just add some brackets here. Because on the top of this fraction it's x squared plus 9x plus 20, things that are added and subtracted automatically get grouped together. So I put blue brackets around that. X squared minus 1 would get grouped together. The 3x plus 15 grouped together. And the 2x squared plus 6x minus 8 would get grouped together. You will be tempted to want to cancel things out. Like some students are tempted to cancel out the x squareds. You cannot, because what's in the brackets right now, the only way a factor can be simplified is if that identical factor is in the numerator and denominator. Or it's a fraction that you can simplify to lowest terms. Right now, nothing matches up. So we have to start to factor. Probably the easiest one to factor is on the bottom of the second one. Can you see that there's a common factor of 3? You can take out that 3, giving you x plus 5. So you don't have to factor these in order. You can factor them however you want. X squared minus 1, can you see that that's a difference of squares? It will be x plus 1, x minus 1. X squared plus 9x plus 20. The only way to get x squared would be x and x. And now these last ones have to multiply to give me 20, so that my outside and inside give me 9x. It's going to be 5 and 4. They would both have to be positive, so that my outside and inside make 9x. Again, every single time you factor, you should multiply it out in your head to double check. And sometimes if you can't factor something, just try something where the first ones work and the last ones work, and you will figure out what changes you need to do to make it work. Sometimes guessing one that doesn't work gives you a hint to find one that does work. I will also tell you that in this unit, they give you hints. Okay? See how we have an x plus 5 on the bottom? And you know how much fun it's been to cancel things out? The people that made these questions also have fun canceling things out, and they're like, ooh, I already saw I had an x plus 5 on the bottom. I would probably guess there would be an x plus 5. If I was stuck, I would try that as my first guess. And same thing here on the bottom. This one, there is, first of all, notice there is a common factor of 2 that you could take out, leaving you with x squared plus 3x minus 4. And that can be factored even further. So I'm going to have to take another line to factor things even further. However, before I do that, at this moment, can you see that this factor is identical to this factor? So I'm going to cancel those out right away. Now, I'm going to rewrite because I'm not done factoring. I still have an x plus 4 on here. I have a 2, and this one is going to be factored to be x and x. I need to get a 4, and I need to get a 1. I'm going to guess it's going to be 4 and 1 rather than 2 and 2, because that would make more things cancel out. Outside and inside, I'm going to get a plus 4x and a minus x to get plus 3x. So now I have factored completely. I already simplified one factor, and now I'm going to look if anything else is identical. Sure enough, the x plus 4s, kind of like a Star Wars theme here. I feel like when you cancel things out, you should sort of make like Star Wars noises. Makes it a little bit more fun. So the x minus 1s will cancel out, the x plus 4s will cancel out. Again, we've done a bunch of canceling. Let's see what we're left with here. On the top, I just have x plus 1. On the bottom, I have a 2 times a 3. That will be 6. For your non-permissible values, take out my highlighter. I'm going to color code things here. We were multiplying, So in multiplying, you just have to check the bottoms. I have a bottom here, but that bottom was fully factored right here. So I'm going to highlight it in yellow. This one I'm going to highlight in green, but it wasn't fully factored until here. Fully factoring also helps you with your non-permissible values. So where the yellow one is equal to 0 is the same place as where this one is equal to 0. And in the yellow one, can you see that x can't equal -4 and x can't equal +1? In the green one, this green one here is the same as the factored version. I can see in the green one that x can't equal -5. So the factored form of the bottom is exactly the same as the original. And the factored form is also what helps us find our non-permissible values. Again, if I gave this to you on a test, I would say simplify each expression and list the non-permissible values if I wanted you to list the non-permissible values. If I say just simplify, and you didn't list the non-permissible values, perfectly fine, 100%. Okay? So I will be very clear if I want you to list the non-permissible values. The answer key in the textbook is doing it. It's good practice to think about it all the way through, so when you do the questions for homework, the answer key has the non-permissible values listed. You might want to try to do that as well, but I'll be very clear on quizzes and tests when I want you to do that. Can I erase this first one? Okay. For the second one, I'm going to factor first, completely. So I have x minus 2. On the bottom, I can factor out a 3, leaving with x minus 7. I still have the divide sign. On the top here, I can factor out a 3, leaving me with x squared minus 4. And on the bottom, I can also factor out a 3, leaving me with x squared minus 4x minus 21. Now, question. Notice that I have 3's on the top and the bottom. Does it make sense that you would be allowed to I'm going to put a red line through these. They're in the same fraction, perfectly fine to simplify those 3's right away. Are you okay with that? Can you see why it would not be allowed to cancel this 3 out with this 3? Because in between those blue 3's is the divide sign. So that's not allowed at this time. You can only simplify when you're multiplying. But you can always simplify within the same fraction. So we would be able to simplify these 3's. Now, I still haven't factored completely. I'm going to take another step. Keep the divide sign. This is a difference of squares, x plus 2, x minus 2. This is a trinomial. To get x squared would be x and x. To get 21 and 4, I'm going to say 7 and 3. I need my outside to be -7, my inside to be +3. I multiply it out completely in my head to check if it works, and it does. Also, certain things that are not allowed at this point. You can't cancel off 2 things on the tops. Because one has to be on the top, one has to be on the bottom. Plus, it's dividing right now. So we can't cancel anything between the 2. You can only cancel when you're multiplying. But what is the rule for dividing fractions? The rule is to multiply by the flip or multiply by the reciprocal. So I can rewrite this one now. These dividing ones, this took a long time for the setup, but now I can flip this. And now I'm multiplying everywhere. Do I have factors that are identical? Yes. X minus 2 and x minus 2. I have x plus minus 7 and x minus 7. What am I left with? I'm left with x plus 3 on the top. It's the only thing there. And I'm left with a 3 and an x plus 2 on the bottom. The factors are different now. Nothing can't cancel out those x's. Can't cancel out the 3's. Because that 3 on the top is grouped together with the x plus. That makes it one factor. As far as non-permissible values in this one, okay? So the reason I factored completely first was for the non-permissible values. Some people like to quickly multiply by the reciprocal. I think that makes finding the non-permissible values just a little bit trickier. Okay? So first of all, I'm going to take out my color highlighting like I did before. I'm going to highlight the bottom of this fraction in yellow, because it's the first one. That one got factored to here, and that doesn't change all the way through. So our first non-permissible value from the yellow one, x can't equal 7. That's pretty obvious.
Or the first one technically be x can't equal 0, because the very first one we have.
But if I put a 0 in for x here, I get minus 21, so 0 is okay. And it's, again, for finding your non-permissible values, it too needs to be multiplied. Because right now, if I put brackets around, this is a whole factor. So you'd have to check, where does that whole factor equal 0, not just the x part. Next, I'm going to take out my highlighter in green. This is on the bottom of a fraction. And I factored it here, which wasn't factored completely, and then I factored it here completely. So from that one, x can't equal 7, and x can't equal negative 3. I'd already written down x can't equal 7, so I added x can't equal negative 3. I find that students who flip this second fraction right away sometimes miss that those were non-permissible values, because they don't show up on the bottom anymore. And if you highlighted it at the top in green, can you see that the first thing I highlighted in green, it's not easy to see the non-permissible values because it's not in factored form. And then finally, take out my highlighter once more, is there any other places that we have dividing by something? Yes. We never highlighted this part, which technically was that originally. But the 3 got simplified, right? Technically that was that, then it was this, and then the 3 went away, which is perfectly fine because the 3 doesn't ever make something equal to 0. But now that it's factored, we also have that x can't equal 2 and x can't equal negative 2. So we have 4 non-permissible values in this one. That can be tricky if you flip too soon. Take your time, factor everything completely first. Then you can, and I like color coding things, can be helpful. Get different colors, highlighters, that can help you. But this one simplifies completely to be x plus 3 times 3 times x plus 2. So, questions for this one are 7, 8, and 12. And these ones are more typical, like on a test, I'm going to get you to factor. Okay?